Hello, this is the continuation of the last video, Rod in a Ball, Part 2. We continue from the last page. This is what we have from the last page. And I repeat the diagram. You have isosceles triangle, phi here, 5 here, theta here, and A, B. And this point is the center of gravity. This vertex is the center of the circle, of the ball. We apply cosine law. So this R square is equal to R square plus A plus B, the whole length, the length of this side square, A plus B square, minus 2 times R times A plus B times cosine phi. So this is the cosine law. R square cancels. I have this part equals 0. I can cancel A plus B. The square is gone, and this A plus B is gone. I have this. From this, cosine phi is A plus B divided by 2R. Once I have cosine phi, I can find sine phi, because sine square phi is 1 minus cosine square phi. So it is 1 minus this squared. To common denominator, I have this. Sine phi is the square root of sine square phi. So I take square root here, I get this. Next, the first part of the question is to prove sine theta equals this. This question we have done sometime before. So we just quote the result. Sine theta is this. This is already proved. Once you have sine theta, you can find cosine theta. So cosine theta squared is 1 minus sine squared. It's 1 minus the square of this. So it's the square of that, To common denominator, I have this. So cosine theta is the square root. It's the square root of this. So I have this. You expand this, simplify. The result of simplification is this. So I have cosine theta. Now, what is cosine phi minus theta? Because I need cosine phi plus theta, cosine phi minus theta, and sine 2 phi. I need the denominator here. So, what is cosine phi minus theta? It's cosine plus sine. So we have everything. Cosine phi, we have everything here. And we have cosine theta, we have cosine theta here. And sine phi, we have here. And sine theta, we have here. So put everything here. put everything into here. And I have this. This can be simplified because I have something common. Now this part, this is common. This part is common. 2r is common. So I can factor out the common part and just do a plus b plus b minus a. Oh. Then if you do that, you have 2b on top, 2r at the bottom, and also this common factor. Once I have cosine phi minus theta, it's very easy to find cosine phi plus theta, because what's the difference between this and this? This is just change this sign to minus. This part is the same except the sign here, minus. So you do that, you change this to minus, and what you have is, instead of 2b on top, you will have 2a on top. The rest is exactly the same as that. So it's 2a here, 2b here, that's the difference. The next, I need sine 2 phi. Now here, I need sine 2 phi. So what is sine 2 phi? Is 2 sine phi cosine phi. I have everything there. Here. I have everything here. Substitution, I get this. Simplify, I get this. So, these are the denominators in here. So once I have this, I can substitute into here and get a new relation, which is this. I have all the denominators here. Then I can find the reactions. R1 is just to multiply this to the numerator of this part. Because W is a given quantity. You are given the rod, so you are given the weight. The weight is W. Yeah. So the W is given. You want to find R1, R2. So R1 is this denominator multiplied into here. R2 is this denominator multiplied into here. So if you do that and cancel something in common, you get R1 is this, R2 is this. So this is what we want to find. The question wants us to find the reactions, right? Yeah. So that is all the part 2 for the same question. The question is, you have a rod inside a smooth hemispherical ball. And this part 2 is to find the reaction at the two ends of the rod. That's all. Thank you for watching. And finally, I have to thank Claire Lee. She presented the solution. What I did here is just to add explanation. That's all. Thank you for Claire. And thank you for watching. Goodbye.